Hi, I'm Peter Leese. I direct the data science lab in UNC's CTSA program in the UNC School of Medicine. I'm going to be talking today about visits and really post-hoc remediation of visits in N3C, the National COVID Cohort Collaborative. And I really don't have enough time to get into a lot of the details of this infrastructure algorithm or sort of all of the baseline fundamental sort of rationale or even that much of our results. But I'd point you to our paper in JAMIA that myself and these co-authors have published out there. And so initially, just a little bit of background and overview of N3C. These are some stats, some of which we have longitudinal data on. The OMOP portion of it, I actually don't have longitudinal data on, but N3C is an extremely large, as far as I know, the largest networked harmonized EHR data activity in the United States by far. And really an effort to bring together data from a huge number of diverse healthcare providers and different institutions, really focused on COVID and COVID sequelae. It started out in probably the range of 40 to 50 sites. Currently, we're somewhere between 75 and 80 different sites submitting data, both a combination of COVID positive patients and non-COVID controls. We're running the entire federal N3C initiative across all of the sub-projects is running somewhere in the neighborhood of 500 projects, over the couple of years that it's been going on. And the OMOP database really behind all of the work is in the order of magnitude of about 23 to now maybe 25 billion rows. And you can see the OMOP specific tables below. And so our focus today on visits, you can see as of April, we were up around almost the 1.5 billion rows order of magnitude. And just to really start out thinking about a little bit of pipeline that happens in N3C. A lot of this happened before I joined N3C. So I don't actually have some of the details on original rationale, but with many different sites, what's happening is each individual site is extracting data from a CDM. It could be OMOP or it could be a different CDM, and then sending that data to a centralized partner that does ingestion and harmonization, OMOP transformation. And then the decision was made initially that all of the transactional encounters would only get loaded to visit occurrence. So when N3C first started architecturally, visit occurrence was the only table that was really getting loaded with visit data. And it was getting loaded with really what I would call transactional atomic encounters. And so just as a brief tangent, for those of us that really work with EHR data, and especially hospital EHR data, you're probably familiar with what an approximately sort of idealized inpatient length of stay distribution looks like. This is from MIMIC 3, but you can see relatively small numbers of extremely short stays, 0 to 1 day, with a central tendency somewhere around 2 to 3 typically. This is very common across hospitals. Yeah, this is the slide that we were on, looking at this sort of idealized inpatient length of stay distribution from MIMIC 3. This is what you actually see when you just look at inpatient visits from that baseline visit occurrence table in the N3C OMOP database. So you can see extremely distinct, very far removed from what you would think of as kind of anything even remotely close to an inpatient length of stay distribution. The individual colors here are the individual sites contributing this data or these visits. And so at this point, there was a lot of commitment to the ETLs and the extractions and the data ingestion and harmonization pipelines. And so the N3C group really moved to a concept of post-hoc remediation, of visits data to try and refine these visits into something that we thought was really closer to actual inpatient visits. And in doing that, we really looked at a lot of, the visits data coming in from 70-something sites, and tried to figure out what was happening. I mean, this is by far the largest and most diverse OMOP database I've looked at. I mean, sometimes we talk about this as sort of OMOP in the wild, what practical building of this looks like between, dozens of sites. But we basically saw lots of heterogeneous issues, probably both intentional and unintentional. So we saw, lots of sites doing things like breaking longitudinal stays into sequential 0-day visits. We saw lots of sites taking the professional components of inpatient stays and labeling them as pure inpatient stays, giving them distinct visit occurrence IDs. And so the mass effect of this over the 70-something sites were many different distinct problems that we couldn't really resolve with one or two fixes. And that's where the solution was to really come up with this post-hoc remediation process. And so this is a diagram of the Macrovisit process. And I think that this looks like something that probably all of us have done some version of, those of us that work with EHR data, at various levels locally or within networks, which is this concept of taking atomic or transactional encounters and bundling them using various types of logic to group things together into some sort of overarching visit type. And so here you can see, there are a range of different visits really occurring sequentially or very close in time that get bundled into Macrovisit 1. You can see there is some period of time here greater than or equal to 1 day where more visits happen. Anything past that point begins to look at getting enucleated into new Macrovisits. So really, this was a way of looking at atomic encounters and trying to come up with logic to group them together back into longitudinal stays that would be representative of hospital care or inpatient stays. So, that pipeline that I referred to before, this is what it really winds up looking like today. So you still have ingestion and harmonization, transactional encounters get loaded to visit occurrence. This Macrovisit algorithm runs against visit occurrence. And then we basically generate an additional sidecar table, which looks like the visit occurrence table with the addition of a few columns. There's a column for a new ID, basically something that would look like a claim header ID or a Macrovisit ID in this case, that's the same between all of the transactional visits that are bundled together into the hospitalization, and then just with a master start date and end date for those macro visits. So this is what's alive in N3C today to facilitate this. What we saw when we generated baseline macro visits was a large reduction in very short stays, particularly 0-day stays, a relatively small reduction in longer length of stays. So you surmise from this that many of the issues we're seeing are in these extremely short length of stay visit types. But you can see it's still also fairly far from what you would think of as an idealized sort of negative binomial approximate distribution. And so we actually layered a second algorithm on top of this that we call the high confidence hospitalization algorithm. This is a method of really looking at the amount of data attributed to macro visits based off of the concept that true hospitalizations will be extremely data dense compared to false positive hospitalizations. And so we look at all of the attributed data and metadata of the macro visits and really put some filters in place to then filter macro visits down to things that additionally appear to be not just bundled multi-encounter or multi-visit care delivery, but truly data dense, high resource utilizing hospitalizations. And so we're drawing a cutoff here approximately where the yellow becomes orange. And you can see from that, you really get a distribution much closer to what we were seeing from that mimic distribution for inpatient length of stay. And so just very quickly to think about or look at some of the results, we look at results across a variety of different aspects. One is just looking at the way data sort of flows from baseline visits to macro visits to to high confidence hospitalization macro visits. What you basically see is this trend towards more, moving from one to the next across all sort of aspects of data that you look at. I think, reviewers wisely point out that doesn't mean that you're actually putting together stuff that should be together. It just means you're putting stuff together, not necessarily related stuff. And so the response to that was to take something very specific, in this case, ECMO, and look at aspects of ECMO that really have to occur. So for one thing, ECMO is almost impossible to occur. For one, it is impossible to occur in an outpatient setting. For two, it's virtually impossible to provide ECMO in a short-term inpatient setting. You're going to have to be in some amount of longitudinal stay. Secondly, there are things that have to accompany ECMO. So in this case, we looked at the lab partial thrombin time and compared inpatient visits to basically inpatient macro visits. And what we saw or could demonstrate was in inpatient visits with ECMO attributed to them, the median length of stay was 0 days, which is basically impossible. I mean, we were demonstrating pretty clear fundamental data issues and could show that the median length of stay in the macro visit version of that was 33 days, a very feasible number for providing ECMO. Same thing on the necessary partial thrombin labs. So the median for inpatient visits, baseline visits, is 0 labs performed at each ECMO inpatient visit. And then moving to the macro visits, there are 25. So what we were basically showing is this was our sort of attempt to show that when we were bundling encounters together into macro visits or hospitalized macro visits, we're not putting random things together. We do appear to be putting related things together, as demonstrated by this attempt to put the things that need to occur with ECMO back together. And let me stop there. And if you have questions, I can point you to the manuscript, or you can feel free to contact me.